Have you ever wondered what makes up everything in the universe? If not, don't worry. In this video, we will learn about the different types of subatomic particles, how they are categorized, and what their properties and roles are. Let's get started. Subatomic particles are the smallest units of matter that make up everything in the universe. They are divided into two main categories: elementary particles and composite particles. Elementary particles are the most basic and indivisible particles, while composite particles are made of two or more elementary particles. The first category of elementary particles is fermions. Fermions are particles that have half-integer spin and obey the Pauli exclusion principle, which means that no two fermions can occupy the same quantum state. There are two types of fermions: quarks and leptons. Quarks are particles that have fractional electric charges and come in 6 flavors: up, down, charm, strange, top, and bottom. Quarks combine in groups of 3 to form protons and neutrons, which are the main components of atomic nuclei. Quarks are held together by the strong force, which is mediated by gluons. Leptons are particles that have integer electric charges and do not interact with the strong force. There are 6 types of leptons: electron, muon, tau, and their corresponding neutrinos. The electron is the lightest and most stable lepton, and it orbits the nucleus in atoms. The muon and the tau are heavier and more unstable versions of the electron, and they decay quickly into other particles. The neutrinos are neutral and almost massless particles that only interact with the weak force, which is mediated by W and Z bosons. The second category of elementary particles is bosons. Bosons are particles that have integer spin and obey the Bose-Einstein statistics, which means that multiple bosons can occupy the same quantum state. There are 2 types of bosons: gaugebosons and the Higgs boson. Gaugebosons are particles that act as the carriers of the 4 fundamental forces of nature: electromagnetic, strong, weak, and gravitational. The photon is the massless particle responsible for the electromagnetic force, which governs the interactions between charged particles. The W and Z bosons are massive particles involved in the weak force, which is responsible for radioactive decay and nuclear fusion. The gluons are massless particles that mediate the strong force, which binds quarks together. The graviton is the hypothetical particle that would mediate the gravitational force, which attracts masses to each other. The Higgs boson is a massive particle that is associated with the Higgs field, a scalar field that permeates the entire universe. The Higgs boson is believed to be responsible for giving mass to other particles by interacting with them through the Higgs field. The second main category of subatomic particles is composite particles. Composite particles are particles that are made of 2 or more elementary particles. The most common type of composite particles is hadrons. Hadrons are particles that are composed of quarks and interact with the strong force. There are 2 types of hadrons: baryons and mesons. Baryons are hadrons that are made of 3 quarks. The most familiar baryons are protons and neutrons, which make up the nuclei of atoms. Protons have 2 up quarks and 1 down quark, while neutrons have 1 up quark and 2 down quarks. Protons and neutrons have almost the same mass and are stable under normal conditions. Mesons are hadrons that are made of a quark-antiquark pair. Mesons are unstable and decay rapidly into other particles. There are many types of mesons, such as pions, kaons, and others, with different quark combinations and properties. The last type of subatomic particles that we will discuss is atoms. Atoms are the smallest units of ordinary matter that retain the properties of an element. Atoms are composed of a nucleus and 1 or more electrons. The nucleus is made of protons and neutrons and defines the element's atomic number. The electrons are negatively charged particles that orbit the nucleus and influence the element's chemical behavior. This list includes major subatomic particles only, and don't forget that other particle types also exists, with ongoing research potentially leading to new discoveries. Each particle has specific properties like mass, charge, spin, and lifetime, which influence its behavior and interactions. Studying subatomic particles helps us understand the fundamental building blocks of the universe and the forces that govern their interactions. This concludes our video on subatomic particles. We hope you learned something new and enjoyed watching. If you have any questions or comments, please leave them below. Thank you for watching.